Hello everyone, welcome back to my channel. Let's continue solving jump game problems. Today we will solve Leetcode problem number 1696, which comes under jump game series only. Let's look at the problem statement. You are given a zero indexed integer array nums and an integer key. Initial position is index 0. In one move, one can jump at most k steps forward direction without going outside the boundaries of the array. That is, one can jump from index I to any index in the range I plus 1 to minimum of n minus 1 or I plus k. And these ranges are inclusive. We need to reach the last index of the array, which is index n minus 1, and the score is defined as sum of all the values of that is nums of j for each index j you visited in the array. We have to return the maximum score we can get to reach the last index starting from 0 index. Now let's look at the test cases to understand it better. I have taken the test case from Leetcode. Here k value is 2. That means from any index, maximum 2 jumps can be taken. We have to start from index 0 and keep on exploring all the possible cells we can visit until we reach the last index, considering the maximum value of score. As we have k options from any node to explore next, for each cell we will consider the maximum score to reach a cell. Hence, if we consider this as a recursion tree, then it will have k branches in the tree. Now let's draw the recursion tree to understand it better. It is mentioned that we have to start from index 0. So if my current index is 0, right, and my value is 1 at index 0, then I can go to either index 1 or index 2 because I can take maximum of 2 jumps. If I go to index 1, then what value I will be having? What value of score that I will be having? 1 plus of minus 1. That means 0. If I go to index 2, then the value will be 1 plus of minus 2. That means minus 1. From 1, again, I can go to either 2 or index 3. If I go to index 2, then my value will be 0 plus of minus 2. That means this one. And from 3, from 1, if I go to index 3, then my value will be 4. From 2, I can go to 3 or I can go to index 4. If I go to index 3, my value will be 3. If I go to index 4, my value will be minus 8. From 2, I can go to index 3 or index 4. If I go to index 3, my value will be 2. Or if I go to index 4, my value will be minus 9. From 3, I can go to 4 or 5. If I go to 4, my value will be minus 3. If I go to 5, my value will be 4 plus 3, 7. From 3, I can go to index 4 or index 5. If I go to index 4, my value will be 4. If I go to index 5, my value will be 6. From 4, I can go to 5 or 6. 6 is out of the boundary, so not possible. If I go to 5, my value will be 5. Again, from 3, I can go to 4 or 5. If I go to 4, my value will be minus 5. If I go to 5, my value will be 5. From 4, I can go to 5 and 6. 6 is not possible. If I go to 5, my value will be minus 6. From here, I think this is minus 3, right? Okay. I can go to 5, 6. 6 not possible. minus 3, 3 is 0. From 5, I have already reached the last index, so nothing to explore. From 5 or 6, not possible. If I go to here, its value will be 7. Now see, okay, again, still I have 4 here, right? So 5, this is minus 5, so minus 2, 6, which is not possible, right? See, I have reached the last index, which is 5, and what values I have? I have minus 2, 5, minus 6, to maximum is still 5, then 0, so 5, 7. So this is a maximum value, right? So the maximum score to reach index 5 is 7. And which path we are taking? We are considering this path. This path, I think we are considering. Okay, this path we are considering. That means the indices are 0, then 1, then 3, then 5. If you consider the values, 1, minus 1, 4 and 3. If you sum all of them, that is 7. So this is a recursion tree for this problem. And as you can see, we have the overlapping problems here, because see, multiple overlapping problems. 4 minus 3, we are multiple overlapping problems, like for each cell. This is one overlapping problem. 4 minus 3. Yeah. So we are exploring like multiple nodes. We are exploring single node. We are exploring for the many times, right? So we have the overlapping problem. Now look for the optimal solution. As recursion approach is having overlapping problem, let's look at the optimal solution. Now look carefully. We have to reach the last index, right? Hence, to get the score, we have to consider the last index value. If we want to reach last index, this value we have to consider, right? Along with this value, we need to pick the value from previous k cells, because to reach this index, we can have options from any, we can reach from any previous k cells, and this is true for all the cells. So if we repeat the same thing for all the cells, we will finally get the maximum sum value to reach any index I starting from index 0. For example, to reach last index, we have to consider, like, how can I reach index 5? Either from index 4 or from index 3. Now, to get the maximum score, we have to consider value 3, right? With this, there are two options to reach index 5, either index 3 or index 4. And which one you want, which value you want to pick? We want to pick the maximum value, right? So what is the maximum of these two? Is 4. So we will pick 4. That means 7. Now the same thing is true for this cell, the same thing is true for this cell, right? So from index, if we want to reach index, for example, if we want to reach index 2, this index, right? So there are two options. Either I can go from index 0 or index 1. In these two way only I can reach index 2, right? Now to reach index 2, I have to consider the value which is at index 2, which is this value. Plus I have to consider the maximum of these two. So what value I will consider? 1. So this is minus 1. So this is true for this cell also. The same thing we have to repeat. So if we start from if we repeat the same formula for each of the nodes, eventually we will get what is the maximum score to reach last index starting from index 0. Let's write on this problem to understand it better or to understand how this thing works. So do the dry run. My starting position is index 0, and this is the starting position, right? So the value is itself the score. Now next I can go to index 1. Now how can I go to index 1 from index 0 only, because I cannot go across the boundary of the array. So I have to consider minus 1 plus, there is only one option, right? From index 0 and the value is 1 only. So the maximum score to reach index 1 is 0, right? So here, mm, maximum value to reach index 1 is 0. Okay, I will update this value. Now, will be the value to reach index 2? I have to consider minus 2, which is the value at index 2. And then there are two options, right? One is from index 0 or index 1. Now, this maximum score to reach index 0 is 1. And the maximum score to reach index 0 is, the index 1 is 0. So I can take the maximum of these two. Minus 2 plus 1, it is minus 1. Now index 3, I have to consider 4 plus the maximum value of, I can go, okay, let's update this value to minus 1. Now I can go from index 1 or index 2. Now what is the maximum value to reach index 1? Which is 0, and maximum value to reach index 2 is minus 1. So this value will be 4. Now let's do the process for index 4. Okay, let's update this thing. This will remain 4. Okay, so we have to consider minus 7, and then the maximum value of to reach index 2 and reach index 4, this is minus 3 because I'm picking 4 only. Now for index 5, I have to consider 3 plus the maximum value of, okay, let's update this thing to minus 3. Okay, I can go from index 3 with the value maximum score to reach index 3 is 4, and maximum score to reach index 4 is minus 3. I'm picking 4, so the value is 7. 3 plus 4, 7. So this is the maximum value.
So to summarize this solution, for each cell we need to find the maximum score from the last k cells. That for each cell we need to find the maximum array of size k. Now, while coding we can sort or find the maximum for each cell, and this will take order of k log k time to sort the array of size k. Hence, the total time complexity will be order of n of k log k. Why? Because we have total n number of cells, and for each cell we are sorting the array of size k. Now this is a huge time complexity. Now to optimize this thing, we can use another data structure, which is priority queue. Priority queue is a sorted array, and internally it used heap data structure. With this, we can optimize the time complexity. Let's code this using priority queue. Here we have given vector array of nums and integer value of k. So first let take the size of nums array, and as we discussed, we will be considering a priority queue, and that will be a pair. Pair why? Because we want to store the index to identify whether the current index which I am exploring from the priority queue lies within the case size or not. Okay, and priority queue is by default it is a maxi of the first index, right, of the first value. But here we are using a pair of elements, right? We need maxib, but the pair maxib value maxib will be formed based on the second value from the pair. So we need to write our own comparator logic. So for that, I will do my own comparator. Okay, and let's name it with PQ, priority queue. So pair will be index and then value at index. Okay, so first I will push 0 index and nums of 0. That means to reach index 0, we got the maximum score, which is value of nums 0. Now let's take one index and loop it from 1 I less than ni plus plus. So currently, then in this way I will explore each cell. So my current value will be nums of I, and we need to find the maximum score from the previous k cells, right? So we need to explore the priority queue until it is empty, and current index minus priority queue dot first is greater than key. I will do the pop operation. That means even if the maximum value is present at the top of the priority queue, but the index, that means top of index of first value from the top, if it is the difference between current index and that index is greater than k, then we won't be able to consider that maximum value, right? So we keep on popping that element. And if priority queue is not empty, then okay, let's get one more value which will do my maximum score. Let's have it 0. So here my maximum score will get updated to my current value plus priority queue of top of second, right? And then we will push this pair of I and this maximum score, right? Once we complete this, we will return maximum score. So at any point of time, priority queue is not of size k, but at max it will hold size k, because here we are popping the unrequired elements, right? Maximum. Now we have to write our own comparator. So following the syntaxes that we use here. Okay, it is operator which will take pair 1, pair 2, and as you know, by default max priority is defined is implemented by maxip, but whenever we have to implement in some main heap, we have to send the comparator as a greater. So it's kind of opposite notation that we have to send. So pair 1 of second of pair 1, if it is less than, then we will return true, else we will return false. Okay, I think this will work. Okay, let me put a semicolon here. Let's run this. Again, some syntactical issue. Okay, it has to be this one. Okay, it got accepted. Let's submit this code. Okay, it's giving me wrong answer. Why? Nums is -1, 2, 3, so single element. Expected -1, 2, 3, I see. Okay, the max score here, it will be nums of 0, right? Because we are returning this. Let's submit. Because of single element, right? Okay, it got accepted. So that was an edge case. So be careful of this edge case. Max score has to be initialized with nums 0. When test case is like a single element array. Okay, this is an example of edge case, right? Okay, now to consider the time complexity, see here we are running it for n number of cells, and for each cell what we are doing here, we are popping, so that is fine, right? We are popping this thing, so that will take order of log k time, plus here we are pushing, right? So this will again take order of log k time, because at max the time size of the priority queue will be order of k. So the total time complexity is order of n log k, and base complexity is order of k. Now if we use sorting, right, sorting approach, then the time complexity was how much? Order of n of k of n of k of log k. So here we have eventually optimized the time complexity, right? Now here we can further improve the time complexity. How? We can, this is constant, right? We have to run it for each cell, but we can optimize this part of the code, right? So if we can use a different data structure in this place, in case of priority queue, then there is a chance to optimize the time complexity further. Can you think of some data structure here? Definitely, we can use Deque data structure. Why? Because Deque is not a sorted array, but it provides the capability to push from front and back of the array, right? So with that feature, we can use Deque in case of priority, in this place of priority queue, and we can make this time complexity of order of n, because pushing and popping here, the main time complexity from in the priority queue is like pushing and popping the elements, right? So if we use Deque, then we can do that operation in order of constant time. So we can optimize this time complexity further to order of. So with sorting approach, we have seen time complexity is required is order of n k of log k, and with priority queue, the time complexity is order of n log k. So for the priority queue, the main time complexity is like pushing and popping the elements, which is of log n or log k. This part, order of n, which is constant, right? Because we have to execute this code for n or explore for n number of total cells. So if we can optimize this pushing and popping operation in constant time, then we can further reduce the time complexity, right? Then is there any data structure which support all this kind of facility with pushing and popping of elements in order of constant time? Yes, the data structure is Deque. While priority queue is a sorted array, Deque is not a sorted array, but provides all the facility that we can get from priority queue. So in Deque, we will be storing all the required elements. Now, what do you mean by required elements? Required element means all the elements which, or the potential elements means those elements lies between the previous case cells, and they can be the maximum value. Okay. So in Deque, the time space complexity will be order of k, because at max k element will be stored, and the first element will be always the maximum score that we can consider. Right? In Deque, we won't be storing the values, rather we will be storing the indices, and we will be updating existing nums array this array which is given, and we will get the index from the Deque. The first index will be the index which is having the maximum score, right? In the same, so in that way we will be getting the answer, right? Now let's see how we can do the coding. So we will be taking a Deque. It won't be a pair, but also array of integers, right? And at first we will be pushing the indices, right? Now and let's take the size of the array 5. Let's run it for all the elements. So nums of I, right? Nums of I means, so front element in Deque mentions the index which is having the maximum score, and that index is reachable within the k range. So nums of I will be the score of nums of I will be nums of I plus nums of Deque front, this one, yeah, right? What is the index in Deque front? We will get the value. So nums of I after this line of execution of line 15, nums of I will represent the maximum score that we can get to reach index I from index 0, right? Now we have to push this element. How? Because going forward this index we can consider, right? Because this will be for the next set of elements, this will lie within the k range, this index I, right, for the following indices. One more condition for this nums of I to get considered is nums of I should be greater than whatever the value is present in the Deque, right? So what we do for that, we will check while Deque is not empty and nums of I is greater than equals to, I will discuss why I'm considered equals to as well. Nums of Deque dot back. Okay, then I will do back. Why equals to? Because if the same value is already present, then my potential index will be I, not the previous one. So that's why I will be removing that element, right? Once I have this thing, I will push the current index. I will push it from back, right? Now we have to check whatever maximum value is present in the front. We have to remove that, right? So while again Deque is not empty and I current index I minus Deque of front, it is greater than equals to k, I will keep on removing from front, right? So first push it and whatever elements are beyond the k indices, remove those indices. At the end, I will return nums of n minus 1 because each index I'm populating, right? Let's run this and see if it is working fine or not. Okay, it's giving me wrong answer. Why? Okay, it's Deque, not TP. Anywhere else? Okay. Okay, it's got accepted. Let's submit it. It got accepted, right? Now, few things here. You understand what is the space complexity of Deque, why we are pushing using greater than equals to in case of comparing the values, and also why we are using greater than equals to while comparing the indices, and how we are storing the data in the Deque, right? Now see how the time complexity will be for Deque. Space complexity is always order of k because the Deque will have maximum k elements stored because of this condition check, right? And here this operations are of order of one constant time, and this element is order of k time only, so that is kind of constant only, right? So it here time complexity is order of n plus of some constant time, so the time complexity is of order of n. So we have seen how we can use the recursion method. I think we have seen the recursion method for this. Then to optimize it, how we can use sorting. Then improving the time complexity further, we have used priority queue. Now to improve the time complexity further, we have used Deque. So I hope you have understand the pattern to solve this kind of problems. So let's to understand the pattern first and grasp the concepts at one go to explain these things in interview better. Hope this video will help you a lot. Thank you for watching. Stay tuned for my upcoming videos.